All right, thanks, Heather. Thanks all for having me. I'm really excited to be here. As Heather mentioned, my name is Donovan. I'm an assistant professor at the University of Florida, and I'm going to be talking about changing large wildfire regime dynamics in the eastern U.S. I'll preface that I normally walk around, so I'm going to try really hard to glue to the microphone, but I apologize if I shift a little bit. So before I begin, I just want to acknowledge the different co-authors that I have on all the different works that I'm going to be presenting today, Drs. Ray Crandall, Jen Phil, and Carissa Wonka, as well as my past graduate students, Noah Weidig and Michaela Ivy, along with all the funders that supported this work. So many of us are familiar with headlines like these coming out of the Western United States. We're seeing these large destructive wildfires. We don't often associate these types of wildfires with the Eastern United States. However, the East is not a stranger to large and destructive wildfires. For instance, some people might remember the Smoky Mountain wildfires. We had multiple fatalities, millions of dollars in damage. And we're seeing more and more headlines in recent years about these large wildfires. We had wildfires burning every borough of New York City a few years back. We had wildfires burning in North and South Carolina in hurricane-affected areas. And most recently now we've got wildfires burning in Florida and Georgia associated with droughts. And so when I first started in the Southeast back in 2022, one of the first things that I wanted to do is look at large wildfire regime dynamics and how they might be changing in the East. So I did this using, with my colleagues, I did this using MTBS, Monitoring Trends and Burn Severity database wildfire perimeters from 1984 to 2020. We looked across 35 different level 3 ecoregions in the eastern temperate forest, which is the grayed out area on these maps here. So first of all, I just wanted to look at what are the patterns in large wildfire in the East. So in this map here, we've got wildfire number, and the darker the orange color, the more large wildfires have occurred over our study period. You can see that we have a lot of wildfires occurring in the central Appalachians as well as the southern coastal plains, but almost every ecoregion in the eastern US has experienced a large wildfire. Patterns in wildfire size, we see that our largest wildfires are occurring in the southeast along the eastern coast, as well as in the southwest corners in Arkansas, Louisiana, Texas. And then when we look at patterns in wildfire area burned, we see that they largely reflect patterns in wildfire number, which makes sense. The East is prone to smaller but more frequent fires. When we look at changes through time, then how these patterns are changing, we used Mann-Kendall's tau, which is an indicator of the strength and directionality of a trend. So the darker the red color, the stronger the increasing trend. The darker the blue color, the stronger the decreasing trend. What you can see is that most of our ecoregions across the Southeast, where we had the most data to conduct these analyses, we're experiencing increases in large wildfire number. We also see patterns in certain ecoregions for increases in large wildfire size. And of course, then we have increases in the total area burned, which are reflective of kind of both patterns in wildfire number and size. So we are seeing increasing large wildfires across this region. When we think about increasing large wildfires, one of the first things that we want to then talk about is the WUI, the wildland-urban interface. This is the region where wildland vegetation and urban development intermingle. And it's the location where we see the greatest risk to human life and settlement. And we really care about the WUI in the East because it's extensive. So in the map that I'm showing here, the red and the yellow areas represent wildland-urban interface. And you can see how expansive it is across the East compared to other regions of the country. So we have a really high probability of exposure, even from slight increases in wildfire, just because there's so much more wildland-urban interface in our region. So my past graduate student, Noah Weidig, was really interested in looking at patterns associated with the WUI. Here we're just looking at, and I apologize for the small text, those are ecoregions on the left-hand side there. And we're just looking at the proportion of wildfires that intersected the WUI across different ecoregions. And I'll draw your attention just to highlight the variability here to those two ecoregions I mentioned that have the most large wildfires, the Central Appalachians and then the Southern Coastal Plain. What you can see is the Central Appalachians has over 75%, the vast majority of its large wildfires intersect with the WUI, whereas the southern coastal plain has just over 25%. So there's a lot of variability in these large wildfires and how they're interacting with our wildland-urban interface. When we look at just general patterns in the WUI, we can see in 2020, just the most WUI is in the northeast corner, which makes sense because that's where we have our most dense development. When we look at the relative increases in the wildland-urban interface through time, you can see that our greatest increases are occurring along that western portion of the eastern temperate forest and then down in the southeast in Florida, Georgia area. Now, NOAA wanted to repeat the analysis that we had done previously, looking at just changes in wildfire regime components through time, but he wanted to divide it now by WUI versus non-WUI wildfires to find out if these increases that we were seeing were associated more with the WUI or they were happening outside of the WUI. And so we have the same coloring scheme that we used in our original paper here using Mann-Kendall's tau. What you can see is that the increases in WUI wildfires, while they're still there, are much less strong than what we saw in our original paper. And when we look at non-WUI wildfires, we see that those numbers are increasing substantially more than the wildfires in the WUI. So this is good, right? It means at least a lot of these wildfires that are increasing are happening outside of the wildland-urban interface. But we also wanted to know, well, how are these burning relative to the WUI? How are all of these fires burning with them? So here we're looking at the distance to the WUI of wildfires that burned outside of it on the x-axis. And we're looking at density distributions here. So the red density distribution represents the actual wildfire distribution. The blue represents what we would expect if wildfires were just distributed at random across the landscape. And we've got the eastern temperate forest in the top left-hand corner. And then these three other plots are level 2 ecoregions. So we just scaled up a little bit. And what you can see is that wildfires burn closer to the WUI than we would expect at random. So even though these increases are happening outside of the WUI, there's still a lot of potential impacts that can happen, particularly associated with smoke. We also found that a lot of these wildfires are burning a lower proportion of the WUI than we would expect at random. So even though they are interacting with the WUI, very little of the WUI is actually burning. And if we just focus in on the eastern temperate forest, if you look at the red distribution there, we can see that it's a little bit bimodal. We have this little hump where we have some wildfires that are burning almost all of the WUI, and then a lot of wildfires that are burning a really small proportion. We looked into patterns and ignitions associated with large wildfires in the WUI. What we found is that the vast majority of large wildfires that interact with the WUI are ignited outside of it, and then they spread into the WUI, which has important implications for how we might manage the WUI to reduce wildfire risk. But we also found that a lot of these wildfires burn a very small proportion. And then the wildfires, even though they're less frequent, the wildfires that do start in the WUI tend to burn a large proportion of the WUI. And then just in terms of structural damage and injuries here, what we found is that these wildfires that are ignited outside of the WUI tend to cause much more destruction, damage, and injury compared to wildfires that are ignited within the WUI, just simply because they're more abundant. So there's much more of these that are burning into the WUI, and you can see this in the bar plots here. We've got exterior ignitions in orange and interior ignitions in yellow. And then we've got injuries on the bottom and structural damage and destruction for the top two plots there in the left column. But the other thing we found is that if you do have an interior ignition, you're much more likely to cause some sort of structural damage or destruction. And so there's kind of this trade-off here in management, which is something that we'll need to consider how we want to manage for exterior ignitions versus interior ignitions when we're thinking about managing them. Okay, so that's a big summary of all of the kind of patterns and changing dynamics that we've seen associated with wildfires in the East. Whenever I present this, people then want to know, okay, well, why? Why is this happening and what can we do? So whenever we're thinking about shifting large wildfire regime dynamics, we tend to think about three core factors. We want to think about patterns in ignitions. We want to think about patterns in fuels and landscapes. And we want to think about changes in weather and climate dynamics. And these three things interacting generally help to shape our fire regime. So my lab is particularly interested in fuels and how fuel dynamics interact with large wildfire and large wildfire risk. Most of us are going to be familiar with the map down here from Guyette et al. In 2012, which predicts our historical fire return intervals in the US prior to Euro-American settlement. And we know that the Southeast historically, and the East in general, is some of the most frequently burned regions of the country. So the warmer, darker orange colors represent more frequent fire return intervals. In places like the vast majority of Florida, it's estimated we had an average fire return interval of less than 2 years. And what this did was it created these really important feedbacks with fire and our vegetation. So we have fire burn through that created these open stand structures. It allowed our oaks, as we heard in our keynote address, to regenerate and prevented the establishment of dense vegetation that maintained our open stand structure. Now, after Euro-American settlement, we of course had a lot of land use change. Again, this was already discussed in our keynote, so I'll keep it brief. But then we had this move towards fire suppression and fire exclusion from systems. And this has a substantial impact, as we know, on the structure and composition of our forest stands. So these are images from the famous Stoddard plots out of tall timbers. On the, let's see, on your right-hand side, we've got a 2-year cycle burn frequency. So really frequent fire that's maintaining this really nice open stand structure compared to a stand that's been unburned for a long time. And you can see the substantial shifts in structure and composition. And you can imagine the difference in fire risk that we might have from these two different stand types, right? If we have an open stand structure with a lot of herbaceous vegetation, we're more likely to have a low intensity fire move through the understory. So if we have a really dense canopy with a lot of ladder fuels, we're able to have that fire move from the ground into the canopy and create these really intense fires that's more difficult for us to control and suppress. So my graduate student, Michaela Ivy, just wanted to find out, okay, is woody cover even still increasing in the East? Like, is this still something that might be contributing to changing large wildfire today? And so what she did was she assessed this across every level 3 ecoregion that we studied in our wildfire paper. And she found that every ecoregion is experiencing significant increases in woody cover between 1990 and 2020. We wanted to look at what was contributing to these increases in woody cover, and we wanted to compare specifically whether this was due to forest infilling or land use conversion. So in this map here, the brown areas are locations where we had a greater proportion of woody cover increases associated with forest infilling, so forests becoming denser. And the blue areas are locations where we had increases in woody cover more associated with land use conversion. So you can see in the Northeast, we have a lot of forest infilling, whereas in the Southeast, we have a lot more land use conversion. In this plot here, we're just comparing across all of our different ecoregions on the left-hand side there, how much infilling was due to deciduous, mixed, or evergreen forests, so how much was taking place. And you can see the vast majority of this is associated with deciduous forests increasing their woody cover. But of course, we have some places like the Southern Coastal Plain where it's dominated by evergreen forests. And then when we look at land use conversion, this is a chord diagram. It's a little bit overwhelming, so I'll walk you through it. If you focus on the big green arrow for deciduous forest there in the top corner, what you see is you have this big arrow kind of going back on itself. And what that's showing is that the areas that were deciduous forest at the start of our study period largely stayed deciduous forest at the end of our study period. And so you can see, for instance, if we look, let's see if I can, here we go. At grasslands and shrubs, we have a lot of these being converted over to evergreen forest. We also have some crops and pasture hay being converted over to evergreen forest, which we associate with pine plantation silviculture, which is known to be expanding across the Southeast. We also see things like herbaceous wetlands being converted over to woody wetlands. So we also think that a lot of this is due to woody encroachment as well from fire suppression. So does this even matter for wildfire, which is what I'm talking about today? What we found is that as we increase the amount of woody cover on the landscape, we have a higher probability of large wildfire risk across most of our ecoregions where we had enough data to conduct this analysis. So an increasing red color indicates a stronger positive relationship between these two factors. NOAA was also modeling these dynamics relative to the WUI. I'm not going to spend the time talking about all of his findings, but he also found that the probability of a fire occurring within the wildland-urban interface within the WUI was associated with higher levels of woody cover. So again, high levels of woody cover are associated with higher large wildfire risk in the east. These are really preliminary results, but we want to look more specifically into forest types as well. So what kind of forests are burning? So here what we're looking at, we've just divided the east into north and south. So north is in blue and the south is in orange. And we're looking at different forest types and how much they're burning, which is the darker bar, and then how much they're actually represented on the landscape, which is the lighter bar. And we wanted to see if things are burning disproportionately relative to what we'd expect. So for instance, in the north, you can see this top bar here, we've got pitch pine is burning substantially more than we would expect based on its representation on the landscape. In the south, we've got things like slash pine burning substantially more than we would expect, whereas loblolly is burning substantially less than we would expect. So some interesting dynamics there that we're still working on understanding. And then we're really interested in how these fuel dynamics interact with weather and climate. So particularly because we see this variability in the effects of woody cover across different regions, we're interested in understanding how changes in weather and climate might be impacting the risk associated with woody cover. So first of all, just go through some patterns we've seen associated with drought. We're really interested in drought. And so this is the density plots for wildfires relative to the PDSI, or Palmer Drought Severity Index, under which they occurred. So the red color means we're drier, abnormally dry conditions. The blue color means abnormally wet conditions. And what you can see is we have this bimodal distribution associated with this long-term drought. So this is accumulating over 9 months. So this is long-term drying. And you can see that a lot of our wildfires occur under abnormally dry conditions, which we would expect. But then we also have a lot of wildfires occurring under abnormally wet conditions over the long term, which is not something that we were expecting. So then we looked at short-term drought, which we represented using 14-day SPAY. This is the standardized precipitation evapotranspiration index. And what we found is that a lot of our fires are occurring under short-term drying conditions. So even though they could occur under abnormally moist conditions in the long term, they're burning under short-term dry conditions. And we can see this a little bit more clearly in these graphs, maybe. I know they're a little bit overwhelming, but if you look, we've got the eastern temperate forest in the top corner as a whole, and then all of our different ecoregions. Each of these lines represents different quantiles. So at the top here, this line represents abnormally moist conditions. And then we've got the time of the wildfire indicated by the 0 down here with this line. And then we're looking at 14-day SPAY before the wildfire and then after. And basically what I want to show you is that we have this rapid drying event that's occurring right around the time of wildfire relative to the surrounding time periods. And we're associating this potentially with flash drought conditions driving some of these wildfire patterns. So as I mentioned, we wanted to model this relative to woody cover. We tested a whole bunch of different models to see what variables would be best at predicting large wildfire patterns. We found long-term drought was important, wind speed, vapor pressure deficit, but we also found this significant interaction between woody cover and 14-day SPAY, so that short-term drying. Basically what we found is that if we're at normal conditions, which are represented by this blue line here, woody cover increases our risk of large wildfires slightly, but as we increase or decrease SPAY, so as we get drier over the short term, we see a substantial increase in the risk associated with woody cover. So there's a strong interaction between short-term drying and woody cover dynamics. Again, these are preliminary, but we wanted to see how these interactions changed relative to forest type. And so here we're looking at density plots for Palmer Drought Severity Index. These are all forest types in the south versus the north. And then we have these different forest types. And basically what I want to show you is that certain forest types are burning typically under more moist conditions of the long term. Other forest types are requiring more extreme long-term drought conditions in order for them to burn. But when we look at this again for 14-day SPAY across different forest types, what we find is that every forest type still needs this short-term drying in order to burn, typically. So really important short-term drying effects here for interactions with large wildfire. So in summary, what we've found so far is that wildfires are increasing across the eastern US, and areas of higher woody cover are associated with greater risk for large wildfire. And we're seeing that these effects are more pronounced when they're associated with a short-term drying event, which is predicted to increase in the future across regions of the eastern US. And then we're also finding evidence that there are different forest types burning under different drought conditions, and understanding this could help us prioritize our management. So what does all of this mean? For us, what this suggests is that our forest stand structure and dynamics are influencing large wildfire risk. And as we're seeing this growing threat on the landscape, using prescribed fire to reintroduce that historical positive feedback that maintained our open stand structures historically and promoted these more low intensity fires is going to be extremely important for reducing risk within our landscapes, and as we found as well within the wildland urban interface, where we have a lot of this high risk to people. Another thing I like to note, though, is that wildfire is inevitable within these landscapes, and so we need to prepare for the fact that these are fire-based landscapes. We need to prepare for coexisting with fire and prepare for the idea that we will have wildfires in the east in the future. And with that, thank you so much, and maybe I still have time for a question.